Okay, so what I'm doing here is doing the next series of questions. I suggest you, because I'm going to send you these slides as well, so I suggest you pause and try the question yourself and just use my answers to confirm. Hopefully, these questions will turn up in the kit as well, and so we will be able to. That means I'm just going to record these videos as well to map that. So here it's question 160. Um, So what do we have here? So we have a scenario that says here the management accountant of a business has identified, yes, this is an interesting one, the following information. And if let's draw the graph here. So you have a scenario where it says here's the activity level so I'm going to draw, well, I'll draw my graph here like this. Here's my activity level of 800 and my total cost here is 16,400. And then I mean, I've got a fixed cost and I'm going to call that A over here. And so I have this here. Then I'm told that the fixed costs, so I mean, I'm told that the fixed cost jump, if you like, or increase by 40%. So I'll go a bit more to 900. So when I get to 900, what's happening, right, is this, isn't it? This is what's happening. You have this increase here in the fixed cost. And then you have this kind of continuation here onwards, if you like. And then it now tells me that at 1,200 units, I have costs of 23,600. Yes. So where was I? Yes. So the point here is they're asking what the variable cost is. I can't quite just do my normal, like, it'll just won't. You see what I mean? It won't, because if I did this high-low method as it is, think about it, you can see that the high and I would have the units, but then the distance is not quite, it's not the same distance. I almost need this kind of distance to do that. And so this is probably the high-low method in itself wouldn't work because of this jump. So I suppose my other option is just to do this mathematically and sort of ask the question, well, what is the picture at 800? So the picture at 800 really is that total cost of 16,400 is equal to A plus BX, which is 800. X is 800, right? So I can just write 800B, right? I mean, that's what this is. And it tells me that the fixed costs jump by 40% at 900 units. So I know that here 23,600 is equal to 1.4A, right? Because A is now has increased by 40%, plus 1,200B, right? I mean, it's the same variable cost. I know it's the same variable cost because the slope is the same. I just don't know what it is. I can't find it graphically. And so I need to find, well, it doesn't really matter. I need to just find, I'm looking for B ultimately. So again, in the classic simultaneous equation route, I actually think you didn't have to do that. You could. I mean, it's long-winded. We have A here. I could literally, I mean, this is a class. I'm just showing you all the methods you can use. You could have said, I mean, it's long-winded. You could have said, well, therefore, A is equal to 16,400 minus 800B. I mean, you could have said this, and you could substitute all of this in here. I mean, you could. And then you would have something that looked like this: 23,600 is equal to 1.4 bracket 1600 minus 800B plus 1,200B. And you'd still get your answer, if you see what I mean. I mean, you've eliminated A, and you can find B. It's just the simultaneous equations allow us, well, I think sometimes you can move quickly with them. So for example, here, what I could do is I could just multiply all of this by 1.4, technically, which I feel is what I'm doing here when I really analyze it carefully. This is 1,000. Yeah. Yeah, that was 1,600, 400, sorry. Yeah, there you are. So multiply this by 1.4, multiply this by 1. When I say by 1, it means that this becomes 1.4, so I can eliminate A, and then I can just work and find out what B is, right? This is the standard simultaneous equation route that works. If I multiply all of this by 1.4, what I have, if you like, is 16,400 times 1.4 is 22,960 is equal to 1.4a plus, of course, 800 times 1.4, which is 1120b. Yeah, I mean, that's what I've done if I multiply the whole thing by 1.4. And then, of course, I now have the other equation. So this is equation 1, and I'll call this equation 2. But equation 2 is bigger, so I'll put that on top. 23,600 is equal to 1.4a plus 1,200b. Right? And so I have these two equations, equation 1 and 2. And I can take equation 1 from... now I can just subtract these two together. So I have 23,600 minus 22,960. So I have 640, and that's, of course, 0, of course, and therefore 1,200 minus 1120, and that's ATB, if you like. And so, of course, B becomes, of course, 640 divided by AT, and B is equal to AT, right? And that's really I'm sorry, B is equal to 8. B is equal to 640. So I found B. B is my variable cost. So yeah, I think that's kind of the thing over here. B is equal to 8. Right. And I've done it algebraically. Okay, great. Let's look at the next one. The next one kind of extends it. Well, it's 162. So I've kind of moved the slides up a bit, but you'll see, because this follows on naturally from the question we just did. It's the same question. So in a way, what they want us to kind of find is A. So now I know that B is equal to 8. So I can just apply that. No, but the question here is, I'll apply it here. I know that the fixed costs after 900 units is 1.4A. Yes, because it's whatever A was, and then add another 40%. So I'm just applying it. So when I look at this now, I have here, it doesn't really matter. I'm going to go with 800. Let me just find A first. So I know that 16,400 is equal to A plus 800 times B. And now I know B, and I know B is 8. So 16,400 is equal to A plus 6,400. And A is equal to 16,400 minus 6,400, and A is equal to 10,000. So if A is equal to 10,000, and I know that the fixed costs post 900 units is 40% on top of that, it means that the fixed costs at this level must therefore be 1.4 times 10,000, which is equal to 14,000. Yes, and there we are. So your answer here is D. Your answer is D. Your answer is D. And that's that, really. That's that. Yeah. And let's look at the last one, 161. So again, I know I swapped the numbers around, but it's really the same thing. And I will record when I record this, or hopefully these questions turn up in the kit. I will have recorded sort of question 160 to 162 as a batch, if you like. Okay, great. So the following table shows the number of clients who attended. So let's plot the graph. Again, just follow the graph, plot what you're doing. So these are my lowest and highest points. So I will just say, okay, this is 400. Here, my total cost at this point here is 36,880. And here I have here 460, and then I have here my total cost being 40,000. 40,000, and so I have, oops, sorry, I can't draw a straight line, something that looks like that. And really, again, it's really it's the same magic, isn't it? 40,000 minus 36,880 divided by 460 minus 400. And what I have here is 40,000 minus 36,880 divided, and that's 3120. So this is 3120 divided by 60, and that comes out at 52. So that's 52. So I know my B is equal to 52. I can already see my answer there already. Yeah, here we are. Yeah, so yeah, and I can already see the answer there. But let's just complete it, really. because this wants the equation. It says what can be used to forecast total cost, and total cost, remember, is equal to fixed cost plus variable cost. So I've got 52 over there, and then what I now need to do is to find my fixed costs. I can just apply it in anything. Let's take the 400. So I know that 36880 is equal to A plus 400 times B, and I know B is now 52. So 400 times 52 is equal to, this is 20,800. 36880 is equal to A plus 20,800. And so A is equal to 36,880 minus 20,800. So that's 36,880 minus 20,800, and A is equal to 16,080. And so you have that there. Excellent. And I think that's really the for those questions before we jump into the learning curves. So yeah, great stuff. So as usual, pause the question and then go through it yourself and see how you're doing. Awesome.